With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, a sound source operates at this much frequency and power is also given and the speed of sound is also given, and this is the density, and you have to find out the intensity at a distance of 6 meter from the source, and what will be the pressure amplitude at this point, this 6 meter distance point, and what will be the displacement amplitude at this point. So if I say the intensity at this point, so intensity at this point can be calculated since the power is already given. If you see, power here is 20 watt, right? And if you want to calculate the intensity at a distance of 6 meters, so let's suppose this distance is 6 meter here. So if you make a sphere here, so all the points on the sphere will have the same intensity since all the points are symmetric with respect to this point. And if you calculate the intensity at this point P, so that intensity at point P will be equals to power by area of that imaginary sphere, that is 4 pi r square. So if you see, power here is 20 watt and the area of the imaginary sphere you can calculate, just put the value of r is equals to 6. So power here is 20 and 4 pi and r square is 36, right? So this will be cancelled out by 5, so you will write 5 by 36 pi will be the intensity at this point. Okay, so if you calculate this further, then you will get the intensity. If you multiply it with 1000, then you will get the intensity in milliwatt per meter square, and that intensity will be 44 milliwatt per meter square. Simple. Now let's calculate the second part. What will be the pressure amplitude intensity? If we calculate, so intensity is equals to pressure amplitude whole square by 2 times of density of air into velocity. So density and velocity is already given in the question. If you see, the velocity is 340 and density is 1.2 kilogram per meter cube, and intensity we calculated this. So if you want to calculate the pressure amplitude, so that will be equals to 2 rho intensity times of the velocity. So just put the values here. 2 into rho is 1.2 and the velocity here is 340, and as we calculated the intensity is 44 milliwatt per meter square, so I will write 44 into 10 to the power minus 3. So if you will calculate this, you will get the pressure amplitude, right? So pressure amplitude here will become 6 Newton per meter square. So this is the answer for the second part. Now moving toward the third part. In the third part we have to calculate the displacement amplitude, right? So let's see the relation between intensity and the displacement amplitude. Third part, we have to calculate the displacement amplitude. So let's write down the relation between intensity and displacement amplitude. So intensity is 2 pi square, displacement amplitude s naught whole square, frequency square into rho into v. So if you see, we can write down this s naught is equals to I upon 2 pi square, frequency square, rho into velocity. Now you need to just put the values here. So rho, v and frequency is 2000, right, and power 20. So just you need to put the values which is needed here. So intensity we already calculated, that was the 44 milliwatt per meter square. So I will write it here, 44 into 10 to the power minus 3, and 2 into pi square I am taking it at as 10, and as we seen that the frequency is 2000, so I will write 2000 square, so it will be 4 into 10 to the power 6, and density is 1.2 and the velocity is 340. So just we have substituted the value of all the quantities. So if you will further solve it, you will get 44 into 10 to the power minus 3 upon 32214 into 3.38 into 10 to the power So if you see 6 and yeah, so here 8 will be there, right? So this will be the multiplication. This way you will get after multiplying the denominator, and if you will further solve it, you will get the S naught is equals to 1.16 into 10 to the power minus 6 meter. So displacement amplitude will be this. So if you see here, this is nearly equals to 1.2 into 10 to the power minus 6 meter. So this will be our answer for the third.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.